Every function hides a secret. Every curve has a story. Welcome to the Atlas of Integrals. Hi guys, in today's video we're going to be integrating functions using long division and completing the square. The first example I want to take us through is the integral of 8 over the square root of 12 minus x squared minus 4x dx. Now, at first glance, it may not look like we're working with much, but it's actually not as bad as you think. So the first thing I can do is recognize that this looks to be in the form of the integral of 1 over the square root of 1 minus x squared, which equals sine inverse x plus c. So I know I want to get into that form. Well, the first thing I can do is take out that 8. So I get 8 times the integral of 1 over the square root. And I'm going to rearrange this to do negative x squared minus 4x plus 12 dx. And then I am going to factor out a negative to get 8 times the integral of 1 over the square root of negative times x squared plus 4x. And then this is just going to say plus 12 dx. And now what I'm going to do is complete the square. So I'm going to get 8 times the integral of 1 over the square root of 12 minus, and now completing the square, I'm going to get x plus 2 squared. I introduced a 4, but it's really a minus 4. So I have to introduce now a plus 4. And now I can make this 8 integral 1 over square root 16 minus x plus 2 squared dx. Then what I can do is factor out a 16 to get 8 times the integral of 1 over the square root of 16 times 1 minus x plus 2 squared over 4 squared dx. And now I can take that 16 out. The square root of 16 is 4, and I'll take that 4 out to get 2 times the integral of 1 over the square root of 1 minus, and then this is x plus 2 over 4 squared dx. Now I'm going to let u equal x plus 2 over 4, and then du dx equals 1/4, and therefore dx equals 4 du. So now I have 2 times the integral of 1 over the square root of 1 minus u squared, 4 du. I can take out that 4 and I get 8 times the integral of 1 over the square root of 1 minus u squared du. And now this is 8 sine inverse u plus c. And if I sub back in my u, I get 8 sine inverse of, and I set my u to be equal to x plus 2 over 4. And now I just end with plus c, and that right there is the answer to the first problem. Now the second problem I want to show you is going to be the integral of 12x squared over 2x plus 1 dx. Now, to solve this one, I'm going to use long division. So I'm going to put 2x plus 1, and then 12x squared plus 0x, because there's technically nothing there, plus 0. Now, I have to think to myself, all right, what do I need to multiply 12x squared by to get, what do I need to multiply 2x by to get 12x squared? And that's going to be 6x. So I get minus and 12x squared, and then 6x times 1 is 6x, so plus 6x. Now when I subtract this, this is going to be negative 6x, and I bring down a 0, so plus 0. Now I say, all right, what do I have to multiply by 2x to get negative 6x? That's going to be minus 3. So I do minus negative 6x minus 3, and I get 3 as my remainder. And that means the integral of 12x squared over 2x plus 1 dx can be rewritten as the integral of 6x minus 3 plus 3 over 2x plus 1 dx. And now I can integrate each separate term. So this is going to equal 3x squared, that one I use the power rule for, minus 3x, I use the power rule for that one also, and plus 3 over 2x plus 1. So I'm actually going to have my ln term here, and I can take out that 1, so it's going to be plus 3 times 1/2 ln of the absolute value of 2x plus 1 plus c, and I could just simplify this, so I get 3x squared minus 3x plus 3/2 ln of the absolute value of 2x plus 1 plus c. And that right there is my answer for problem 2. Now, problem 3, I want to do the integral of 4 over x squared plus 4x plus 8 dx. So I can see that this is in the form of the integral of 1 over x squared plus 1, which we know is equal to tan inverse x plus c. So I'm going to complete the square, and I get 4. I'm going to factor out that 4, 1 over, and this is going to be x plus 2 squared. Now, in that, I introduce a 4, so I have to subtract a 4, and 8 minus 4 is 4, so this is plus 4 dx. Then I'm going to factor out a 4 to get 4 times the integral of 1 over 4 times x plus 2 squared over 4 plus 1 dx. Now, I can take that 1/4 out, and I'm back at 1/4 times 4 is 1, so I have the integral of 1 over. Then I can rewrite this as x plus 2 over 2 squared plus 1 dx. I let u equal x plus 2 over 2, and therefore du dx equals 1/2, and I get dx equals 2 du. And then I'm going to sub that back in, so I get the integral of 1 over u squared plus 1, 2 du, and that is going to be 2 tan inverse u plus c, which equals 2 tan inverse, if I sub back in u, x plus 2 over 2 plus c. And that right there is my answer for problem 3. Now, the next problem I want to do is the integral from -1 to 1 of 3x squared plus 2x plus 1 over x plus 2 dx. All right, so this one I can actually use synthetic division, and I'm going to make -2, and I have the coefficients 3, 2, 1. Bring down this 3 times -2 is -6, -2 plus -6 plus 2 is -4, -4 times -2 is 8, 1 plus 8 is 9, so that's my remainder. And this is going to be the integral now of -1 to 1 of 3x minus 4 plus 9 over x plus 2 dx. Now this is going to be 3/2 x squared minus 4x plus, now this is going to be plus 9 times the ln of the absolute value of x plus 2, and I'm evaluating this from -1 to 1. So that's going to be 3/2 minus 4 plus 9 ln of 3 minus 3/2 plus 4 plus 9 ln of 1. All right, so I know that I can subtract out those 3 halves, and I get negative 8, and now this is plus 9 ln 3 minus 9 ln of 1. Well, the ln of 1 is just 0, so this term goes away, and I am left with negative 8 plus 9 ln 3. That right there is my answer to the number 4. The fifth question I want to do is the integral from 3 to 5 of 2x squared plus x plus 4 over x minus 1 dx. Once again, this question I can use synthetic division. I'm going to let 1 be my divisor, and I have 2, 1, 4. I bring down 2, that's 3, that's 7. This is my remainder. So I get the integral from 3 to 5 of 2x plus 3 plus 7 over x minus 1 dx. So this is going to be x squared plus 3x plus 7 ln of the absolute value of x minus 1 evaluated from 3 to 5. So this is going to be 25 plus 15 plus 7 ln of 4 minus 9 plus 9 plus 7 ln of 2. So when I evaluate this now, I'm going to get 40 plus 7 ln 4 minus 18 minus 7 ln 2. So now I get 22 plus 7 ln 4 minus 7 ln 2. And if I want to, I can write this as 22 plus 7 times ln 4 minus ln 2. And if I want to get even more specific, that's going to be 22 plus 7 times the ln of 4 over 2. So finally, it's this 22 plus 7 times the ln of 2. That is my answer for number 5. And the final problem that we're going to do is going to be the integral of 4x cubed over 2x plus 3 dx. Once again, I can use synthetic division, 2x plus 3, 4x cubed, or not synthetic, but long division in this case, plus 0x squared plus 0x plus 0. When I think about what number I have to multiply by 2x to get 4x cubed, that's going to be 2x squared. So this is going to be plus 6x squared. So then I get minus 6x squared, and I carry down a 0x. So now I'm going to have to find out what number multiplied to 2x gets negative 6x squared. That's going to be negative 3x. So now I do minus negative 6x squared minus 9x. That's going to get me 9x. Now I bring down that 0. And now this is going to be 9/2 x. Or I can think of it as 4.5x. I'll just write, just 4.5 or just 9/2. So I'm just going to say plus 9/2. And now I write this as minus 9x. And then that's going to be plus 27/2. So this is going to be minus 27/2 as my final remainder. So now I have the integral of 2x squared minus 3x plus 9/2 minus 27 over 2 over 2x plus 3 dx. And this is going to equal, use the power rule for this, 2/3 x cubed minus 3/2 x squared plus 9/2 x. And then 27 over 2 over 2x plus 3. Well, that's just going to be 20 minus 27/4 ln of the absolute value of 2x plus 3 plus c. And that's my final answer for problem 6. So those were all of the problems we did, and I'll probably have to zoom out pretty far to see all of them. There we are. So those are all the problems, and that was it.